Hello students, welcome to Aditya Academy. I'm Dr. Ragini Arora and today we are going to finish our exercise 6.2 from which we had covered first 5 questions in the previous video, and from question 6 to question 10 we are going to solve now. So in this exercise the sixth question is about, like, we are given that A, B, C are points on OP, OQ, OR respectively such that AB is parallel to PQ. Now I'm writing the given part. Given that AB is parallel to PQ, AC is parallel to PR, and we have to prove that BC is parallel to QR. So now, see, keep this in your mind that BC is parallel to QR. We have to prove this. That means in the last we have to use converse of BPT. But firstly, we will be using BPT to derive results from these two parallel sides. So for solution, now check for the lines parallel. Like AB is parallel to PQ. Where is AB? AB is parallel to PQ. Now where these two parallel sides are falling? They are falling in the triangle OPQ, right? So in triangle OPQ, you always have to mention the name of the triangle before applying BPT over there, right? In triangle OPQ, it is given that AB is parallel to PQ. You can write it as given. So now, if we apply BPT over here, it is OA upon AP, OB upon BQ. OA upon AP is equal to OB upon BQ, right, by BPT. So once we have got this ratios of opposite sides, now check for the next pair of parallel sides. It is AC parallel to PR. It is here, AC parallel to PR. So what is the name of the triangle? ORP. In triangle ORP or OPR, it is given that AC is parallel to PR. So what we can do is we can find the ratio in terms of OA upon AP, OC upon CR. OA upon AP is equal to OC upon CR, right? Again by BPT, by basic proportionality theorem. Let this be the second equation. Now check, do we have, see, we can only apply BPT in two things because two parallel sides are given to us. Now check for the equal or same thing which is common to both the equations. OA upon OP, OA upon AP, sorry. OA upon AP is common to both the sides. So you can write equating equation 1 and equation 2. We can get these OB upon BQ is equal to OC upon CR. Now look for these ratios in the figure. Let me erase this. Okay. This is OB upon BQ is equal to OC upon CR. Right? Now what can we say about this? Let this be the triangle that we are concerned with, OQR. Now you can say from, let this be equation 3. So from equation 3, in triangle OQR or QOR, what we can say about this ratio? OB upon BQ is OC upon CR. These are the ratios of the opposite sides of triangle OQR. So by converse of BPT, we can see that this side BC will be parallel to QR. So when the opposite sides are in the same ratio, divided in the same ratio, we can say that this line dividing the opposite sides will be parallel to the base side. So BC is parallel to QR. This is what we have to prove. Next question is, now using theorem 6.1. 6.1 is BPT. right? Prove that a line drawn through the midpoints of one side, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side, right? So what is given to us here? This is basically the converse of midpoint theorem that we have to prove by using basic proportionality theorem. You had learned this theorem in class 9. This is converse of midpoint theorem. It says that if a line is drawn through the midpoint of one side, so let us assume that D is the midpoint of AB. In triangle ABC, D is the midpoint of AB, right? And if that line is drawn parallel to another side, let this DE be parallel to BC. That means DE is drawn parallel to another side. See, it is the midpoint of one side. Let it is the midpoint of AB. One side we have used. Then it is drawn parallel to another side. Let us assume that it cannot be parallel to AC. So DE has to be parallel to BC. We have used two sides. Then it bisects the third side. We are left with only one side, AC. That means we have to prove that this line is meeting AC at point E. So E has to be the midpoint of AC. E is the midpoint of AC. This we have to prove. So what we can do here, since DE is given parallel to BC, we can start with the basic proportionality theorem. So proving part is here. In triangle ABC, since DE is given parallel to BC, we can take the ratio AD upon BD. AD upon BD is equal to AE upon CE, right? This is by basic proportionality theorem. Okay, now we have to prove that E is a midpoint of AC. So what we can do, one more thing is given to us. D is a midpoint of AB. So if D is a midpoint, we can say that AD is equal to BD given. So the ratio of AD over BD becomes 1 because they both are equal. So if AD over BD is 1, let this be equation 1, this is 2. From equation 1 and equation 2, replacing AD by BD by 1 is equal to AE over CE. We can see that CE is equal to AE, right? And CE is equal to AE implies that E is the midpoint of AC. This is what we have to prove, right? Next is using theorem 6.2. Now what was 6.2 is the converse of basic proportionality theorem. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So this is triangle ABC. Here it is given that this line DE is joining the midpoints of both the sides like AB and AC. What is given to us is in triangle ABC, D is the midpoint of AB. Similarly, E is the midpoint of AC. So the question says, prove that the line joining the midpoints of any two sides. We have already used two sides. Now this line, which has been drawn by using midpoints of two sides, is parallel to the third side. So that means DE has to be parallel to BC. Prove that DE is parallel to BC. Right? So now we start our proof. This is what we can do. We are given that AD is equal to BD. It is given. that D is a midpoint. Similarly, okay, then we can first write the ratio of AD upon BD. If we take BD in the denominator, here become with 1, right? AD by BD is equal to 1. So we have got this. You can write this as equation 1 instead of this, right? Now the next thing is AE is equal to CE. This is also given in the question that E is a midpoint of AC. So we can now take the ratio of AE and CE. This also comes out to be 1. So let this be equation 2. So now from equation 1 and equation 2, these both the ratios are equal to 1. So we can say that AD over BD is equal to AE upon CE. Now what is that? By converse of BPT theorem, we had learned that if the ratio of the two parts of both the sides of the triangle, if the ratios are equal, then this line is parallel to the third side. You can see that AD upon BD is AE upon CE. So by converse of midpoint theorem, by converse of basic proportionality theorem, BPT, we can say that DE is parallel to BC. Right? This we have to prove. Now the next question is, ABCD is a trapezium in which AB is parallel to DC. So we make a trapezium. A, B, C, D is a trapezium in which AB is parallel to DC and its diagonals intersect at point O. This is given to you. So given is trapezium ABCD in which AB is parallel to DC. That is all we have given. To prove that AO upon BO is equal to CO upon BO. So we start our proof, but here, see, we have to find the ratios, and we know that we only can have ratios when we can apply BPT. Now BPT can be applied only in triangles, not in a quadrilateral. We are given these two sides parallel, but they are lying in a quadrilateral. And we have to apply BPT in a triangle. So here we need to do some construction. So write construction here. Draw OE parallel to AB. Right? We cannot say this is parallel to both the parallels at the same time. We can only draw one line parallel to one line, though it is known that since OE is drawn parallel to AB and AB itself is parallel to DC, so we can say that these three lines will be parallel, right? So now these three lines are parallel. What we are going to do is we are applying BPT in this triangle DAB. In triangle DAB. Now focus over here, DAB. What we can do is, since OE is parallel to AB, so we can write DE upon AE is DO upon BO. DE over AE is DO upon BO by BPT, basic proportionality theorem, and it is given that OE is parallel to AB by construction. Right? Let this be first equation. Now in triangle we have to use this line. Next is in triangle, now reverse the triangle. Now focus on triangle ACD. Let me change the color. This, right? Here this side is parallel to this side. So again we can find the ratio in triangle ACD. This line is parallel to this line. So AE upon DE is AO upon CO. AE upon DE is AO upon CO. Let this be, because here OE is parallel to CD by construction and given. So by BPT, we have derived this result by BPT. Let this be second equation. Now see one thing. Here the common thing is this side is common to both the triangles, whether it is triangle ABD or ACD. So here the ratio is in the form DE over AE, but here it is AE over D. So let us take the reciprocal on both the sides. DE over AE is equal to OC over OA. Let this be equation 3. Now you can see from equation 1 and equation 3, this DE over AE is common. So from equation 1 and 3, we can equate these two things. So we write OD upon OB is equal to OC upon OA. Right? This is what we have derived. But see what you have to prove. OA upon OB. Okay, OA upon OB. The only thing is this OA needs to be here and this OD needs to be here. We have to interchange OD and OA. Let me tell you one thing. When we have equation of this kind, a ratio of this kind, A upon B is equal to C upon D. What do we get? A into D is equal to B into C. We can also write this as D upon B. We can bring this B here and C over here, C upon A. Right? So A into D is equal to B into C. Ultimately, see, even if you don't get this, see one thing. What we can do is the product has to be the same. Product has to be same. A into D is equal to B into C. So if we multiply these two, we can write this as OA upon OB is equal to OC upon OD, because the product remains same. OA into OD is equal to OB into OC. This is another way to write this given ratio. This is called alternando. Right? OA upon OB is OC upon OD. So the only thing is we have just changed the order of the ratio. The thing remains same. So hence we have proved what we wanted to prove. The next question is the diagonals of a quadrilateral ABCD A, B, C, D intersect each other at a point O. Intersect each other at a point O. Now, such that OA upon OB is equal to OC upon OD. Given is quadrilateral ABCD in which AO upon BO is equal to CO upon DO. This is the given thing. What we have to prove is ABCD is a trapezium. So we have to prove that ABCD is a trapezium, or roughly you can say that we have to prove AB is parallel to DC. Here you need to remember one construction. Since we do not have any parallel thing through which we can either use BPT or converse of BPT, so we need to draw a line parallel in this figure. So construction is draw EF parallel to AB through O. We cannot say EF is parallel to DC because here we are not given that it is a trapezium. We can either draw EF parallel to DC or parallel to AB, and I have drawn parallel to AB. Now we start our proof. So the parallel things like OE, what triangle we can choose? OE is parallel to AB. So first of all we have to choose triangle ABD. In triangle ABD, what we can do is DE upon AE is equal to DO upon BO. See what is given to us. OA upon OB. OA and OB. See, In the previous question also you have seen that this is not the proper way we can go through this ratio. We have to modify this ratio by, see, D upon A you can write first by BPT, because OE is parallel to AB by construction. I have written all the reasons. So this is your first equation. Now I come to this ratio. What is given to us is AO upon BO is equal to CO upon DO. But we can see that AO and BO are not the fractions or the fractions of the same side of a triangle. They are forming different sides of different triangles. So first we have to modify the ratio. So yes, we can write this as AO upon CO. See, AO and CO are the parts of one side. So we can take this as two different parts of one ratio. And on the other hand, I take BO to this side, BO upon DO. You can only check this. The cross product of these two things should be same even if we change the pattern of the ratio. AO into OD should be equal to AO into OD should be equal to OB into OC. This remains the same. OA into OD is OB into OC. We can change this ratio into this format. So now we come for this. We require ratio in the forms of OA and OC, OB and OD. Now we have got this. OA and OC, OB and OD. So what we can do is, this is now DE upon AE is equal to OD upon OB. OD upon OB. Again we have OB upon OD. So take the reciprocals on both the sides. That means AE upon DE is equal to OB upon OD. Now you can check. Let this be second equation. This was your first equation. Let this be 3. Now compare equation 2 and equation 3. What do we get? OB upon OD is common to both the ratios. So from 2 and 3, we have, leaving this OB upon OD side, we have AO upon CO is equal to AE upon DE. Right? Now AE upon DE is equal to AO upon CO. Can you check this in the figure? See, AE upon DE is equal to AO upon CO. So what we can do? See, the ratio of these two parts on the left hand side is equal to ratio of these two parts on the right hand side, and this is forming a triangle ACD. So in triangle ACD, if these ratios are equal, that means the middle line, this line EO, is parallel to the base line. EO is parallel to DC by converse of BPT. By converse of BPT. So now what we have proved, this EO is parallel to DC, and we know that EO is parallel to AB by our construction. Now we have proved that it is parallel to DC. That means EO is parallel to both. They both are parallel to each other. So we have AB parallel to DC, which proves ABCD is a trapezium. Right? So this we had to prove, and now we have learned to apply BPT in the direct manner and to use its converse. I hope this exercise is clear to you. So we will be back with the next video on similarities of triangles. I hope you liked watching this video. Please like, subscribe and share it with your friends. Thank you.